Hello all. Today we will see the application of time and work formula in solving some numerical problems. So let us start. First problem is A can complete a piece of work in 20 days while B can complete the same work in 30 days. How long it will take for A and B to complete the work together? So there are two individuals A and B and they have different uh, time, they require different time duration to complete the same piece of work as their efficiency rate is different. Now if they work together, how long they will take to complete the whole work if they work together? So that is the problem. So in this case also, first we have to find out their individual efficiency rate. That means how much each individual can complete the portion of the work in one day. So let us first see. So work done by A in one day will be definitely 1 by 20, as we know that A can complete a piece of work in 20 days, right? So A can complete a piece of work in 20 days. So obviously in one day A will complete 1 by 20 of the whole work. Same in the same manner, similar manner, B can complete same work in 30 days. So B's efficiency rate will be, that means B can complete the work in one day will be 1 by 30 of the total work. Now we have to find out their jointly how much they can complete the work, jointly how much, what is the portion of the work that they can complete in one day. So we have to take summation of these two fractions. So work done by A and B together in one day will be obviously 120 plus 130. So you have to take summation of these two fraction, and if you further simplify, you have to take LCM of 20 and LCM of 30, right? And if you further simplify it, you will get 1 by 12. So that is the fraction of total work that will be completed by one day if A and B work together, right? So if A and B work together, they can complete 1 by 12 of 1 in one day. 1 by 12 of whole work in one day. So now the question is, if they can complete 1 by 12 of whole work in one day, how many days will be required to complete the whole work? And as I mentioned earlier in our previous lecture, that in this case we'll just take the reciprocal of how much work is completed in one day. So here also we will do the same. So A and B, since A and B can together complete 1 by 12 portion of the whole work in one day, so number of days which will be required to complete the whole work, that is the total work, that will be just reciprocal of this efficiency rate, or reciprocal of how much they together complete in one day. So 1 by 12, which will give you nothing but 12 days. That is the total amount of work they require to complete the work. So in this kind of problem, first we need to find out the individual efficiency rate, that is how much they can complete in one day. Then we have to take summation. Now once we know that how much, what is the portion of work they can complete together, working together in one day, very easily we can find out the duration, total duration of work that will be completed if they work together, just by taking reciprocal of work completed in one day, right? So 12 days is the answer here. Let's move to the next problem. So problem 2, in case of problem 2 also, A can complete a work in 18 days, where B can complete the same work in 24 days, right? Again here efficiency, their efficiencies are different, so duration required to complete the work alone is different. They start working together, but A leaves after 6 days. So A initially worked for 6 days and then A left. Then how many? Then the rest of the work will be completed by B, obviously. Then the question is, in how many more days will B finish the remaining work? So again here the first step for this kind of problem is to find out that how much they can complete the work in one day. individually, and then we will take summation. So here also, just like the previous problem, is 1 day's work, that is A can complete 1 by 18 of the total work in 1 day, and similarly B can complete 1 by 14, 1 by 24, sorry, 1 by 24, since B can alone can complete the whole work in 24 days. So in 1 day B can complete 1 by 24 of the whole work. And total, if they work together in 1 day, they can complete the summation of these two fraction, which is 1 by 18 by 1 plus 1 by 24, which will give you 7 by 72. If you calculate this, you will find out it will be 7 by 72, right? So together, if they work together, they can complete the work in 1 day. 7 by 72 portion of the whole work will be completed. Next step is, since after 6 days A left, so A and B both work together for first 6 days, then A left. So how much they will complete in 6 days? If they can complete 7 by 72 of the total portion in 1 day, how much they can complete in 6 days? So obviously 6 into 7 by 72. So 6 into this fraction, right? And it will give you 7 by 12. So in 6 days, when they work together, they can complete, by working together, they can complete 7 by 12 of whole work. Whole work is 1. We know that whole work is nothing but 1. Now, after 6 days, so in 6 days, this much of work is completed, and after 6 days, A left. So the remaining work will be completed by B. So what is the remaining work? So obviously, since 1 is the whole work, and this 7 by 12 is already completed, so the remaining will be 1 by 1 minus 7 by by 12, right? So that will be the remaining work. So let us see in the next line that remaining work will be 1 minus 7 by 12, which is 5 by 12. Now this 5 by 12 will be again alone, it will be completed by B alone, since A has already left, right? So how much time it will take for B to complete the work? Again, we will take reciprocal. B can complete his work in 24 days, and in 1 day B can complete 1 by 24. So this much work will be done. The formula is 1 by 24, that is work completed in one day by the remaining work. So the formula is work completed in 1 day divided by remaining work will give you the number of days. So sorry, B can complete the remaining work 5 by 12 divided by 1 by 24, which is 10 days. Right? So it will be actually the remaining work by the how many, what is how much B can complete in 1 day. So remaining work by 1 day, B is 1 day work. That will give you 10 days. That will give you the number of days that is required to complete the remaining work. So it will be remaining work by B's 1 day work. Portion of B's 1 day work, that will give you 10 days, which is the answer. Let's move to the next problem. Problem 3 says that A and B can work together, complete a work in 10 days. B alone takes 15 days to complete the same work. How long A alone take to complete the work? Now here B's, how much B will take, that is given, but how much A can alone complete the work, that is not given. That you have to find out. What is given is A and B together can complete the work in how many days? In 10 days. That is given. And how many days are required to for B to complete the work alone? That is also given, 15 days. Given this two, you have to find out how long A will take to complete the work. Right? It is very simple. So since joint work is given and B is alone work, how many days is required is given. From this, you can easily find out how much time it will take for A to complete the work. So again we will go by this, that how in how many days A and B together can complete the, what is the portion that A and B together can complete in one day. So the portion is obviously 1 by 10, right? Just like previous two problems. So together A and B can complete in one day is 1 by 10. Since B alone can complete the work in 15 days, so B's efficiency rate, or B can complete the work in one day, is 1 by 15 of the whole work. Okay, so these two are very simple. Now if we subtract this from this, so we are basically subtracting B, A plus B minus B, right? A plus B minus B. So B and B will cancel out, and you will all only left with A. So same here, we will same rule we will apply here, right? So A's work in is 1 day work will be 1 by 10, which is A plus B, minus B's 1 day work. So this one minus B's 1 day work. So 1 by 10 minus 1 by 15 will give you 1 by 30. You have to take LCM of 10 and 15, and after subtracting you will get 1 by 30. So A alone in one day can complete 1 by 30 of the whole work. So how many days it will be required for A to complete the whole work? That is one, nothing but reciprocal of this. So 1 by 1 by 30, that is 30 days. In 30 days A can alone complete the whole work. So it is nothing but 1 by 1 by 30, just reciprocal of this problem of how much they can complete in one day. So in 30 days A can complete the whole work. So it is very simple problem. Next problem is it is related to payment. Okay, so here there are not only A and B, but a third entity is also there, who is C. So A, B and C can complete a work in 20, 30 and 60 days respectively. So A can complete alone a whole work in 20 days, B can complete a whole work alone in 30 days, and C can complete a whole work alone in 60 days. From here, we can easily find out how much individually they can complete in one day. They are paid a total of 1200 for their work. How much should A receive? Okay, so let us see step by step how we can solve this problem. So first we have to find out jointly in one day what is the portion of the work they can complete. So we know that how much A can complete in one day. One day A can complete 1 by 20. Okay, that is A's efficiency rate. In one day B can complete 1 by 30, as it is given mentioned here. And in one day C can complete the work 1 by 60. Okay, so if we take sum of these three, we will get how much, what is the portion of the work that is to be completed in one day by these three individuals, 1, B and C, if they work together. If they work together in one day, what is the portion of the work that will be completed? So just take the sum of their efficiency rate. That means how much they can complete individually in one day. So 1 by 20. So it is 1 by 20, 1 by 30 plus 1 by 60. And if you take LCM, okay, after taking LCM, we'll do the addition, and then you will find out 1 by 10 of the whole work to be completed in one day if these three individuals A, B and C work together. So in one day together they can complete 1 by 10. So how much time it will take to complete the whole work? So total work to be done if they work together will be obviously the reciprocal 1 by 1 by 10, that the total work will be completed in 10 days if they work together. Okay, so all three will have to work 10 days. all three will have to work in 10 days. Okay, say A will work 10 days, B will work for 10 days, C will work for 10 days. Now here we are concerned about A because we have to find out how much A will receive as payment. So A has also worked for 10 days. So if A can complete 120 of the total work in one day, then in 10 days, what is the portion that A will complete? So A's contribution in 10 days will be 10 into 1 by 20. Why 1 by 20? Because this 1 by 20 is completed in one day by A. If A work alone, this 1 by 20 is completed in one day, right? So how much will be completed in 10 days? Say 10 into 1 by 20. So 10, here it will be 2, right? And finally we'll get 1 by 2. So half of the work will be completed by A in 10 days. So that means A completes half work. Half portion of the work is completed by A. So A's share in this payment will be half into 1200. So because 1200 is the total payment and A has worked half, so half portion will be paid, half portion of the payment. If the workers are paid according to their work proportion, that is obviously implicit assumption that each worker is paid as per their work proportion. So if A is paid as per their work proportion, half payment will go to A. So half of 1200 is 60, right? So the answer is 60. A's share of payment will be 600. I'm extremely sorry. It is 600. Half of 1200 is 600. Right? Let's move to the next problem, which is related to pipe and cistern. So it is an application of time and work formula. So it is another kind of problem, but it is the same rule or same steps we will follow to solve this kind of problem, pipe and tank related problem. So here a pipe can fill a tank in 12 hours, right? While another pipe can empty it in 18 hours. If you can recall, while explaining formula, I told you that the pipe which can fill a tank, that is called inlet pipe, and that work is considered as a positive work. So it is a positive work. While the pipe which empties the tank, it considered as negative work, and it is called inlet pipe. So here the positive work done by this pipe, which it can fill the tank in 12 hours, where another pipe is there where it can empty the tank in 18 hours, and both the pipes are open together. I mean, this is a little bit unrealistic. We do not generally open both the pipes, but here, if both the pipes, suppose mistakenly it is both the pipes are open, how long it will take to fill the tank? First thing is whether it will fill the tank or it will empty the tank. Whose strength is higher? Okay, that we have to find out. Since A's efficiency rate is higher because A can fill in less number of times, but the pipe that empties the tank takes higher number of hours. Here the pipe which can fill the tank takes less number of hours. That means efficiency is more, because we know that when duration is less, efficiency is more. When duration is more, efficiency is less. So this pipe which can fill the tank is more efficient. So obviously the positive is strength of this pipe is higher than strength of this pipe which can empty the tank. So obviously the tank will be filled. But in how many hours? Let's see. So the pipe that fills in 1 hour is 1 by 12. So here also we have to find their efficiency rate in 1 hour. So the pipe fills in 1 hour is 1 by 12 portion of the whole tank, right? The emptying pipe drains in 1 hour 1 by 18 of the total amount of water that is to be filled in the tank, right? So if we just subtract 1 by 18 from 1 by 12, we will get in 1 hour how much? actually will be deposited, how much water will be deposited in the tank. Because one pipe, there is, suppose this is the tank, one pipe is filling it and another pipe is emptying it, right? Another pipe is emptying it. Since this has a greater strength, this pipe has a greater strength, so water will be definitely filled. But in how many hours? Right? So if we just subtract that, because this is minus and this is plus. So let us see. So net work done in 1 hour will be 1 by 12 minus 1 by 18. Why net work? Because it is filling, the one pipe is filling the tank in 1 by 12 hours, right? But another pipe is actually emptying the tank. So it is a negative work. So one is doing the positive work, one is doing, another is doing the negative work. Okay, and their joint work will be 1 by 36, right? So in 1 hour, 1 by 36 portion or fraction of the total tank will be filled with water, right? So if 1 by 36 portion of the tank is filled in 1 hour, then how much time it will take to completely fill the tank, considering considering that the whole tank is equal to 1, considering that whole tank is equal to 1, so how much time it will take to fill the whole tank? If it is in 1 hour, if it is filled 1 by 36 of the whole tank. So obviously we have to take, just like the previous problem, we have to take the reciprocal of it. So time required to fill the tank will be 1 by 36, which is 36 hours. So to fill the entire tank while another pipe, emptying pipe, is also open, it will take 36 hours. Right? Next problem is, here there are both the pipes, but both the pipes are emptying the tank. But scenario is, pipe can fill a tank in 10 hours, another pipe can fill the same tank in 15 hours, but it is opened 5 hours later than the first pipe. So here both the pipes are filling pipe, inlet pipes. There is no outlet pipe in this problem. So both the pipes are inlet pipes, but one pipe is open after 5 hours. In how many total hours will the tank be full? So how many hours it will take the fill the entire tank? So obviously individual efficiency rate of these two pipe we have to find out. So the first pipe is pipe A, or first pipe, we can call it first pipe. Work done by pipe A alone is 1 hour. Work done by pipe B. So another pipe, here we will mention that another pipe is pipe B. Later another pipe is pipe B. So pipe B can alone fill the tank in 1 by 15 as it is given here. Okay, so individual efficiency rate we are calculating. Then together, how much water they can fill in 1 hour. Okay, so no, first we have to find out that how much, because pipe A is pipe B is opened 5 hours later than the first pipe. So pipe A, in the first 5 hours, pipe A is only working. So in first 5 hours, pipe A is only working. Pipe A is only filling the tank. So if pipe A in 1 hour can fill 1 by 10, right? Then in 5 hours, it can fill 5 into 1 by 10 equal to half. So half of the tank will be filled in first 5 hours by pipe A. Because in first 5 hours only pipe A is open and pipe B was not open. Right? Half of the tank is filled in the first 5 hours by pipe A. Work done by both the pipe in work. Now we will find out how much work done by both the pipe in 1 hour, right? So 1 by 10, that is the individual efficiency rate of pipe A, and individual efficiency rate of pipe B is 1 by 15. So jointly, if they are open, they can fill 1 by 6 portion of the entire tank. So jointly, if they are open, they can fill 1 by 6 portion of the entire tank. So time required to fill this remaining portion is obviously half is filled in 5 hours. So remaining is half. So remaining remaining amount of water is half. Okay. So half of the tank will be filled in half by 1 by 6, because after 5 years both the pipes are open. So the rest half will be filled by both A and A plus B. So the remaining half amount will be filled by both pipe A and B. This remaining half amount will be this remaining half amount will be filled by both A and B. So how much time then it will require? So half by 1 by 6. Okay, since 1 by 6 is their joint efficiency rate in 1 hour. So it will take 3 hours, because 1 by half by 1 by 6, actually it will reverse. So it will be 6. So 2 and 6, you will get 3. So the tank will be filled, the remaining half of the tank will be filled in 3 hours. So total time to fill total time to fill the tank will be 8 hours, because first 5 hours work done by A, filled by pipe A, and the rest half will be filled by both the pipes together. So it will be 8 hours. It will take 8 hours to fill the tank completely. Okay. So this is for today. These are the problems related to time and work, and also an application of time and work, which is filling tank or emptying tank kind of problems. Thank you very much.